let us start with the first question. The area of the region enclosed by the ellipse x square plus 3y square is equals to 18 in the first quadrant below the line x is equals to y is. So here we have been provided with an ellipse. So let us convert it into a standard form. What do we get? X square upon 18 plus y square upon 18 by 3, which makes it 6. This is equal to 1. So this becomes our standard equation of ellipse. That means, first of all, the center of our ellipse is 0, 0. So now if we were to draw the diagram of this entire situation, first we draw our coordinate axis, of course. Here we see that A is of course greater than B, so it is going to be a horizontal ellipse. So let's say this is our ellipse. Now we've drawn our ellipse. Now what are they saying? That there is also one more line which is y is equals to x. So let's say this is our y is equals to x line. So this intersects this ellipse at some point. And they have told us we have to find out the area enclosed between the ellipse and the line in the first quadrant. So in the first quadrant, of course, this is the portion. And they've also told us that the portion below the line. So let us shade the portion. Of course, every time whenever you get a question which is based on area on the curve, you must draw the diagram and shade the portion that you are trying to find out. So this is the portion that we are trying to find out. So how can we find out the area now of this entire thing? First, let us try to find out this point of intersection here. What is this going to be? Let me put the value of x is equals to y in this equation. What am I going to get? X square plus 3x square is equals to 18. So from here we get x to be 3 by root 2. I hope you are understanding. This would become 4x square. Taken below, this would become 9 by 2, and taken under root, this would become 3 by root 2. So this is 3 by root 2 comma 3 by root 2. What are my points of what is the center here? Center is 0, 0, which is my origin. And what is this point, which is my vertex of the ellipse? This is going to be a, 0. What is my a in this entire equation? This is 3 root 2, 3 root 2, 0. Again, these are just properties of ellipse that we are using. So this point here basically is my 3 by root 2, 0. Now I hope you all can see that from 0 to 3 root 2, this portion, it is bounded by the straight line only. So simply I can say that this is my first portion of the area that I'm trying to find out. Let's say if this is my first portion of the area that I find out, what would be my second area? Second area from 3 by root 2 to 3 root 2. This area is bounded by the ellipse. This area is bounded by this ellipse. So I can find it out in two parts. Let this be my A1. Let this portion be my A1. And let this portion be my A2. So my answer would be, my total area would be basically A1 plus A2. So my A1 would be integration from 0 to 3 by root 2. Y is equals to x. So it would become x dx. Plus A2 is 3 by root 2 to 3 root 2. And here I would have to put my equation of ellipse. So if I was to convert this equation of ellipse in terms of y, how would it be converted? It would become y is equals to 18 minus x square by 3 whole root under. So here I would have 18 minus x square upon 3 whole root under dx. Now let us find out this values and we would find our answer. So this would be equal to x square by 2, value goes from 0 to 3 by root 2, plus here we would have, let me take the constant term outside, 1 by root 3, and inside we are going to be left with 3 by root 2 to 3 root 2 root under 18 minus x square. Now I hope you all remember we had done this type of integration in indefinite integration while we were studying. What we do is we consider 1 here and we apply by parts integration in this entire question. So after applying by parts, what do we get? Let us put the values, or first let us do the entire integration and then we'll start putting down the values. Plus this becomes 1 by root 3, and after applying by parts, what are we going to get? I'm directly writing down the answer. You must also, and I had told you that this was a standard form, a square minus x square root under, which you must remember. So upon writing down, this becomes x by 2 root under 18 minus x square plus 9 times of sine inverse x by 3 root 2. So I hope you all can perform the by parts integration or look at our previous lectures in indefinite integration which we had done, and the limits are from 3 by root 2 to 3 root 2. Let us put the values. What are we going to get? This would become 9 by 2 to the 4 plus this would be 1 by root 3, and here if I put the values 3 by root 3 root 2 first of all, so this would become 3 by root 2 into root under 18 minus x square, so this entire term becomes 0. 18 minus 3 root 2 whole square is again 3 root 2 whole square is 18, so 18 minus 18 we get 0, and here we would be left with 9 times of sine inverse 1 minus what are we going to have here? This would become 3 by 2 root 2 root under 18 minus x square, so 18 minus 9 by 4, this would be 18 minus 9 by 4, sorry 9 by 2, 18 minus 9 by 2 minus 9 times of sine inverse 3 by root 2. If we put 3 by root 2, so this would become 1 by 2. Let us simplify this even further. What do we get? 1 by root 3. Sine inverse 1 is basically pi by 2, so we would have 9 pi by 2 minus 3 by 2 root 2, and 18 minus 9 by 2, this becomes 36 minus 9 by 2. 36 minus 9 by 2 is 27 by 2, so this would become, sorry, let me write it down in a in separating format of numerator and denominator. So below we would have root 2, and above we have root under 27, which is basically 9 into 3, so it becomes 3 root 3 minus, and sine inverse 1 by 2 is pi by 6, so we have 9 pi by 6. So from here what we can see is, let us do the calculation further here. This is 9 by 4 plus 1 by root 3, and we have 9. Let us subtract 1 by 2 minus 1 by 6, so that after taking 9 pi common, what would we have? After taking 9 pi common, we would have 1 by 2 minus 1 by 6. What is it going to be? Let us do that here. We would have 1 by 2 minus 1 by 6. I have taken 9 pi common from this entire equation, so what would we be left with? 3 minus 1, which makes it 2 by 6, so it is 1 by 3, minus, here we would have 9 root 3 upon 2 to the 4. Now from here 3 and 3 can get cancelled out. Once we multiply root 3 inside, what is our final answer going to come out to be? It is going to be root 3 by root 3 pi. So this is how we calculate our answer. So again, in this question you must of course draw the diagram. Of course, anytime you have a question which is related to area under the curve, it is recommended that you first draw the diagram and then try to solve the question. If you are not being able to find out the let's say enclosed area directly, then try to divide it into several parts and then solve the question. For example, how we did here, we divided the entire shaded portion into two parts, one which was bounded by y is equals to x curve and the other one which was bounded by the ellipse. So from there we found out our answer. Let's look at another question. If the area of the region a by x square is less than equal to y is less than equal to 1 by x. So in this question we do not have to draw the diagram or do not have to worry about anything about y. They have already given us the upper curve and the lower curve. This is our lower curve and this is our upper curve, and they've given us the limits as well. From 1 to 2 they've given us a certain value, so we have to find out the value of a. So our area would be nothing but integration from 1 to 2, and we would have 1 by x minus a by x square dx. Simply, we do not have to worry anything about the diagram or anything. So let us directly integrate this. We would have ln x minus a by x, sorry, this would become plus a by x, and the limits are from 1 to 2. Let us put the limits. We would have ln 2 plus a by 2 minus ln 1 becomes 0 and minus a. So basically we have ln 2 minus a by 2. this is our area. Now they've told us that this value is equal to log E2, or log E2 can also be written as ln2. So let us write this down. ln2 minus 1 by 7, this is equal to ln2 minus a by 7 that we just a by 2 that we just calculated. So from here what do we get? This and this gets cancelled, minus cancels out among itself, so a is equal to 2 by 7. So we found the value of a. Now what is the question asking? We have to find out the value of 7a minus 3. So 7 times of what is the value of a that we just calculated? It is 2 by 7. So from here we get this 2 by 7 minus 3. 7 and 7 cancels amongst each other, and we would have minus 1 as our answer. Very simple question. In the question itself, they had given us the upper function and the lower function that told us that y is basically bounded by 1 by x and a by x square. So we do not have to use our brains or logic much in this question. Simply just 1 by x minus a by x square would give us our answer. Let's look at another question. The area enclosed between the curves. Now this is a good question. What you have to do first of all here, of course, whenever modulus has been given to you, and inside the modulus you can see that there is only x here. So let us try to transform this equation in terms of both these curves into two different curves. One when x is greater than 0 and one when x is less than 0. So what can we say about the first curve? Y, this value would be equal to x square. X, this modulus x would basically become positive x, because we know when we have mod x, that time this mod x is equal to x when x is greater than 0, and this mod x is equal to minus x when x is less than 0. I hope you all remember this property of modulus that we had studied. So this would become x square when x is greater than 0, and this would become minus x square when x is less than 0, because mod x would turn into minus x. What about the second curve? Talking about the second curve, again when x is greater than 0 and x is less than 0. When x is greater than 0, this would be plus x, so x minus x makes it 0, so we would have y is equals to 0. Basically this is our x-axis. And when x is less than 0, so this would convert into 2x. So I hope you've gotten this portion. Now let us draw the diagram based on these values of y that we've gotten. So how can we draw the diagram? Let us first do for x greater than 0. For x greater than 0, we know that first curve, we have y is equals to x square. So our curve would be somewhat like this. And for the other one is our x-axis, so it doesn't matter much. Now for x less than 0, we have the first curve, we have minus x square. So had, let's say, this been x square only, that time our curve would have been this way. However, now we have minus x square. That means for every x value that has been squared, that value would turn out to be a negative value of y. So the curve would simply become this way, the opposite of this curve. I hope you are understanding how we are getting this. Now for this one, x less than 0, we have y is equals to 2x. So this curve of course would pass through the origin, and we would have a curve like this, straight line. Y is equals to 2x is a straight line, and this is our curve that we have. Now we have to find out the area enclosed between the curves. So this is the area that is enclosed between these two curves. This is what we have to find. Now for here, let us find out this intersection point between these two graphs. What is our first graph? First is y is equals to minus x square, and other one is y is equals to 2x. Let us put the value. What do we get? 2x is equals to minus x square. From here x and x gets cancelled, so we have one of the points x to be 0, which is our origin, and what would be our other point? X would be equal to minus 2. So this point here, this would become minus 2, comma, and if we were to find out our y, this would become minus 4. So these are the points that we found out. Now what can we do is, instead of finding it on the x-axis, let us find it on the y-axis, because it would become easier for us. If we find the area on the y-axis, what would happen is we can simply subtract this function minus our straight line, because if we look at this entire curve, if we shift our entire coordinate axis by rotate it by 90 degree, what would happen is that this curve would become our upper function and this curve would become our lower function. So we can simply do that, and our limits would also be in the terms of y, so it would be from minus 4 to 0, and the curve that we have here is, firstly we have root under minus y, and the lower curve that we have, it is y is equals to 2x, so it becomes y by 2. This would become dy. Or if I was to write this in a better way, this would become 1 by 2. Now let us try to solve this entire thing. How can we write down this equation? Now let us solve this integration that we've gotten. How can we solve this? Again, in the simplest format that we've studied, this would become minus 4 to 0. Sorry, this would, let us remove the limits and directly write down our integration. This would become y to the power 3 by 2 upon 3 by 2. Minus sign goes outside. This would be minus y square by 4, and we have to put our limits from minus 4 to 0. So first let us put 0. Everything gets cancelled out because y becomes 0, so our entire term becomes 0. This would, and all of these terms would become positive since we are going to subtract it from minus 4, so it would become, so this thing would become minus minus plus 4 to the power 3 by 2 upon 3 by 2 minus, here we would have minus 4 square by 4. So from here what do we get? For 4 1 by 2, this would become 8. Sorry, this is 3 by 2 here. 8 into 2 by 3, and minus, here we would be left with, this would become 16. 16 by 4 would give us 4. So from here we can say this is 16 minus 12, so which makes it 4 by 3. This is our answer. Now of course I did this entire question in terms of y because it was easier solving in that way. You could have also done it in the terms of x. How would have I will also show you the integration in terms of x. You could have written minus 2 to 0, and we do right function minus the left one, so it would become minus x square minus of 2x dx. You could have done it in this way also. It would be the same thing, give you the answer in the same way. So this was a good question that was asked. You had to use the properties of modulus function here in this question. Definitely a question you should practice once again. So let's move on to the other one. One of the points of intersection of the curves y is, so a quadratic equation has been given to us, and y is equals to 1 by x, our hyperbola, rectangular hyperbola. So they've given us one point of intersection. Let the area enclosed by these curves be this. So basically we have to find out the area enclosed between these two curves. So what is our first equation? It is minus 2x square plus 3x plus 1. Now what if I was to draw the diagram of this entire curve? Of course I know that my a value in this quadratic equation, in ax square plus bx plus c, a is negative. So in this question a is less than 0. That means I would have a downward parabola, downward curve. So now how would my downward curve look like? So let us first find out if it intersects the y-axis or not. Let me put the value of x to be 0. So here if I put the value of x to be 0, what is the value of y that I'm getting? It is plus 1. So that means my curve is intersecting the coordinate axis at some positive y. And if let's say I was to put y is equals to 0, what am I going to get then? If I put y is equals to 0, this would become 0 is equals to 2x square minus 3x minus 1. If I was to solve for x, this would become 3 plus minus root under 9 plus 4 2s are 8. So this makes it basically 17 upon 2a, which is 4. So I have two values of x, which is 3 plus root 17 by 4, and I have 3 minus root 17 by 4. So this value is of course negative. That means my curve would somewhat look like this. This would be my curve. Of course, my maxima that I'm talking about for this curve. So the maxima that I would have for this curve, it would be lying somewhere in the positive x. So this point here that I've gotten, this is 3 plus root 17 by 4 comma 0, and this one here, this would be my 3 minus root 17 by 4 comma 0. And now what other curve has been given to us, or let me write down one more point, this is my 0 comma 1. Since at x is equals to 0, my quadratic curve basically cuts the y-axis at 1, and my other equation is y is equals to 1 by x, which is my rectangular hyperbola, which we know looks somewhat like this. So our first point of integration they've given us, this is our second point of integration. So we have to find out these 2 points, and we have to find out the area enclosed between these 2 curves. This would be my area that I have to find out. So let us first find out this point, the point of intersection between these 2 curves. So one of my curves is y is equals to minus 2x square plus 3x plus 1, and my other curve is y is equals to 1 by x. Let us put the value of y to be 1 by x. We would get 1 is equals to minus 2x cube plus 3x square plus x. So from here we have 2x cube minus 3x square minus x plus 1 is equals to 0. And from here, what are the values of x that we can get? From here, this can convert. Now they've told us that one of the values of x is 1 by 2. That means I can say that this equation would be satisfied by 2x minus 1. Now let us divide this entire equation by 2x minus 1. Basically, they've given us a point of intersection so that our calculations become easier. That means one of the roots we've found out. What would be our other 2 roots that we have to find out? Let us divide this equation. What would we get? We would get x square. From here, this would be x square, and from here we would have minus x and minus 1. This would become our other part of the equation. This is equal to 0. Now we know our first point, which is x is equals to half. What would be our other point from this equation? X would be equal to minus b plus minus root under b square minus 4ac, which makes it 5 upon 2a. So this becomes 2. And we, of course, my hyperbola is going to be here as well. However, we do not have to find out that point, because they've told us that one of the points is this. That means they're only talking about the first quadrant. So we shouldn't be worried about our second quadrant. So we can simply eliminate the negative 1. So our answer would be root 5 by 2. So this point here that we've gotten, our first point of intersection, here we have x to be 1 by 2, comma whatever the y is, we don't care. And in our second point of intersection, we have x is equals to 1 plus root 5 by 2. And again, we do not care whatever the y is. We simply have to integrate our equation from 1 comma 2 to 1 plus root 5 by 2 comma 0. So again, our upper function is our quadratic equation and our lower function is our hyperbola. So let us do that. Our integration, our limit goes from half to 1 plus root 5 by 2, and our upper function is our this one. So this becomes 2x square plus 3x plus 1 minus 1 by x dx. Now if I was to solve this entire integration, I would get minus 2 x cube by 3 plus 3x square by 2 plus x minus ln x. And I have to put values from 1 by 2 to 1 plus root 5 by 2. Now upon solving this, what do I get? Let me put all these values. I get minus 2 by 3. Here below I would have 8 and 1 plus root 5 whole cube. So let us find that out here. 1 plus root 5 whole cube. So first let us square this term. What are we going to get? Let us make this square into 1 plus root 5. What are we going to get? 1 plus 5 plus 2 root 5 into 1 plus root 5. So this 1 plus 5 can be written down as 6. So from here we would get 6 plus 6 root 5 plus 2 root 5 plus 5 2s are 10. So this becomes 16 plus 8 root 5. So here we have 16 plus 8 root 5, and we can take 8 common from this. So we would have 2 plus root 5 left here, and this 8 would be removed. Plus 3 by 2. What was our x square? X square would become 6 plus 2 root 5. plus x. X is our 1 plus, sorry, here below we would also have, since it is by 2, so we would have 4 here as well. X is 1 plus root 5 by 2 minus of ln x 1 plus root 5 by 2 again, minus now this entire term, so this would become plus 2 by 3 1 by 8 minus 3 by 2, this would become 1 by 4 minus 1 by 2, and here we would have plus ln 1 by 2. Now let's try to open this entire equation. From here what are we going to get? Minus 4 plus, sorry, this would be minus 4 minus 2 root 5 by 3 plus, from here I can cancel out 2 by taking 2 common, so I would be left with 3 plus root 5, so this would become 9 plus 3 root 5 upon 4 plus 1 plus root 5 upon 2. Let's take all the constant terms together and keep the ln terms aside. From here we would have plus 1 by 4 3s, so this would become 12 minus 3 by 8 minus half, and here we would have plus ln 1 by 2. This ln 1 by 2 of course would cancel out with the minus ln half, because of course let me show it to you here. How can we write down our minus ln 1 by root 5? It can be written down as minus ln 1 plus root 5 plus ln 2, and this equation plus ln 1 by root 2, it can be written as minus ln 2. So from here this would cancel out and we would be only left with, this would become minus ln 1 plus root 5. Now let us see what was the value that was given to us in the question. They had told us that this value is equal to n log e 1 plus root 5. So from this entire value that we've gotten, we can see that our n value would of course be 1, because there is just one ln term that we have. So we've gotten our n to be 1. Let us find out our m and l. So what would be our coefficient of, let us do it directly. So what would be our coefficient of root 5 basically in this equation? Our coefficient of root 5 would turn out to be, taking minus 2 from here, 3, 4, 2, taking all of this LCM, we would be left with, we would have some value that is let's say 14. If I am taking 1 by 24 common here, of course it would be 14 root 5 plus what would become my constant from this entire equation. Now again I have taken 1 by 24 common, so I have to be careful with that as well, and here I would be left with 15. Yes, let's check it once again. So this would, my LCM would become 24, correct, the LCM is correct, which is 24. So from there, yes, so from here what do we get? Our L value to be 14 and M value to be 15. Now what had they asked us? They've told us that L plus M plus N is equal to, so from here if I add all these three values, L plus M plus N, this would give me 30, and this is my answer. Again an easy question, although it was very lengthy because the calculations were pretty heavy in this question. Apart from that, the concepts that were used were very easy. Area under the curve, the concepts of area under the curve are very easy, so that was all that was used in this question. Let's look at another question. Now let's look at this question. Here again they have already provided us with an upper function and a lower function. However, this is a cos and sine function, so we have to be careful. We cannot directly apply the formula that we had studied of upper minus lower function. So let us try and draw the diagram. I hope you all remember we had studied in trigonometry about the graph of cos x minus sine x, and that too when it's in modulus. So how would our graph become? Let's say this is my 0. At 0 what would happen? Sine x would become 0, cos x would become 1. So our graph would be somewhat like this. And here the value at which this becomes 0, this would be pi by 4. So this is basically our graph for cos x minus sine x. So now let us apply that graph here in this question. What do we have here? They've told us that we have to take x from 0 to pi by 2. So let's say this is my 0. So at 0, so basically this is how my graph is going to look like when I talk about cos x minus sin x modulus. So this is my modulus of cos x minus sin x. This value here, this is my pi by 4, and of course this value here, this is my pi by 2. Because at pi by 2, cos x would become 0 and sin x would become 1. However, this entire value would turn out to be minus 1 since it is in modulus, so it is going to be up, which is my minus 1 here. And now let us draw our upper function, which is sin x. Sin x at 0 is 0, at pi by 4 it's 1 by root 2, and at pi by 2 it becomes 1. So basically our function of sin x goes somewhat like this. So this is our sin x function. At pi by 2 it is 1, and at 0 it's 0. At pi by 4 its value is somewhere around 1 by root 2. I hope you all remember. Now there is one intersection point here. So first, before we get into that, let us find out the shade the area that we need to find out. So it is from sin x bounded by sin x and cos x minus sin x. So this is the area that we need to find out. I hope you all are understanding that we are not going to go for this portion of area, because here sin x is less than cos x minus sin x. We have to find out only that area where sin x is greater than cos x. So let's say this value here at the intersection point, let's say this is our angle phi. So from phi to pi by 2, we can see that sin x is greater than cos x minus sin x. So basically this is the area that we have to find out. Now how can we find out this area? We simply cannot integrate it from phi to pi by 2. Phi we can find it out. Phi would be of course the intersection of these two curves, and we can simply equate these two curves and find out our phi. So that is not a problem. Let us talk about the area, how we can find out. We simply cannot integrate phi and pi by 2 because that would give us this area as well. And if I subtract my cos x minus sin x from that as well, it is going to give us some different answer. Because up until here, my graph was cos x minus sin x. However, now at this portion, my graph has changed to sin x minus cos x because it is in modulus. And of course, in modulus, of course, it has to be always positive. And from pi by 4 to pi by 2, you can see that this curve would be minus f of x. So it would become sin x minus cos x. So we have to try and solve this in a different way. So let us divide this entire area into two different parts. Let us keep it from here to here. So we are going to basically integrate from phi to pi by 4. And we will integrate from pi by 4 to pi by 2. So this would be our answer. Of course, 0 cannot be included here. We cannot include all these portion here because of course cos x minus sin x is greater than sin x in those portions. So we cannot take that. Now first let us find out our phi. So cos x minus sin x, let us make this equal to sin x. From here what do we get? Tan x equals to 1 by 2. So from here we can say that x is equal to 1 by 2 and x is nothing but our phi. Phi is equals to tan inverse 1 by 2. Now let us let it be as it is. We'll later on see how we can use this formula. So our phi is nothing but this phi here is tan inverse 1 by 2. So now let us try to integrate from tan inverse minus 1 by 2 to pi by 4. What is the value that we are going to have? Here we have sin x, and here the curve is cos x minus sin x. So we would have sin x minus cos x minus sin x. This would simply open up as it is. It would be positive only. And we have to find out our integration from pi by 4 to pi by 2. Here our equation would become sin x minus. Now our equation for this one would change. It would become sin x minus cos x. Sin x minus cos x. And this entire we have to find out our dx integration. So now let us solve this entire equation. What do we get? From here, of course, you all can see this would become 2 sin x minus cos x. So from here we would be left with 2 sin x minus cos x integration dx, plus here we would have integration sin x and sin x would cancel out, and here we would be left with cos x dx. Let us integrate this. We would get minus 2 cos x. Cos x integration is sin x, and these two we have to integrate it from tan inverse half to pi by 4 plus cos x integration would become sin x, and this we have to integrate from pi by 4 to pi by 2. Now let us put down all the values and see what we are getting. From here we would have minus 2 cos pi by 4. Cos pi by 4 is 1 by root 2. So this would be minus 2 by root 2 minus sin pi by 4 is also 1 by root 2. Now since both of these values are minus and we have to subtract our lower limit, so this would become plus 2 cos x. So this would become 2 cos of tan inverse half plus sine of tan inverse half plus here we would have sine pi by 2 which is 1 minus sine pi by 4 which is 1 by root 2. Now let us find out the value of these two terms first. So basically our tan inverse half, this which we call as phi, if this is phi, that means we are trying to find out the value of cos phi. Sorry, this is, so we are trying to find out the value of cos phi. If let's say tan phi is 1 by 2 and this we know this is perpendicular by base. So if we know the value of perpendicular, we know the value of base. Can we find out hypotenuse? Yes, my hypotenuse would be h square is equals to p square plus b square, which would be equal to root 5. So my h would be equal to root 5. If I found out my hypotenuse, so I can say my cos phi would be equal to base by hypotenuse. So this becomes 2 by root 5. And my sin phi would be perpendicular by hypotenuse. This is base by hypotenuse. My sin phi would be perpendicular by hypotenuse, which can be written as 1 by root 5. So we found out these values as well. Sine of tan inverse half is nothing but sin phi, and we found out sin phi. So let us put down all these values. What do we get? Minus 1 by root 2 minus 1 by root 2. This would become 2 by root 2. So we would have minus 4 by root 2 plus 1 plus this would become 2 times of cos phi is nothing but 2 by root 5. So this becomes 4 by root 5 plus this would become 1 by root 5. So this becomes 5 by root 5. Basically this value transforms into root 5. And what do we get ultimately from here? This can be told to be 5 plus 1 minus 2 root 2. So this is our answer. This was only asked in the question. We had to find out the area of region A. So I hope you must have understood this question. First and foremost, the most important thing is for you to draw the curve of cos x minus sin x. Once you draw the curve of cos x minus sin x, you know it is under modulus, so it is always going to be positive. So the values that used to be below the x-axis, it would become the mirror image in the x-axis, so it would go up. So that is what exactly has been done here. And draw the graph of sin x as well from 0 to pi by 2, they've told us. Now from 0 to pi by 2, they've told us that y is always less than sin x but is greater than modulus of cos x minus sin x. So you have to take up only this shaded portion, because only in this shaded portion my sin x is above my cos x minus sin x. So that is why I choose this. And you have to remember that from 0 to pi by 4 my modulus would open as positive. However, from pi by 4 to pi by 2 my modulus would open as negative. So that is why I had to divide it into two different parts and then calculate my answer. Now another catch in this question was that the point of intersection of these two curves, I assume it to be phi, and I find out the value of phi to be tan inverse half. Now I cannot really find out the value of phi in terms of any degree. So what I do is I find it out as perpendicular by base, and I find out my hypotenuse, and then I calculate my cos phi, sin phi, and then I use it in finding the integration. So this is how this question is done. Let's move on to the next question. Let q be the maximum integral value of p for which roots of the equation this are rational. So first let us find out this portion of the question. This does not involve, of course, our area under the curve concepts. So this basically involves our quadratic equation concepts. So first let us find out the value of q. What have they told us? That this quadratic equation, the maximum value of p for which this entire equation has its roots rational. That means what we can say is our curve needs to be somewhat like this upward curve, and it needs to just touch the x-axis. Because if I, let's say, take a little bit of value q which is greater than this maximum value, my curve would go a way lot above x-axis, and of course it wouldn't have rational roots, it would have irrational or imaginary roots. So this is exactly where I would have the maximum value. So what can I say about this point when my curve is just touching the x-axis? What can I say? That this would have equal and real roots. And for equal and real roots, what we had studied, that always my discriminant is equal to 0. So now for this equation, this quadratic equation that we have, which is 4x square minus 4px plus 5p is equals to 0, I have to make my discriminant equal to 0. And discriminant, there has to be real and equal roots. That means my discriminant also needs to be a perfect square. Now, of course, I can take my value of discriminant to not be a perfect square. I can get two values of roots as well. However, for that, my q wouldn't be maximum. My q would be some other value. My q would be maximum only when I have the graph just touching the x-axis. So d should be a perfect square and it should be equal to 0. So from here, what do we get? Sorry, d shouldn't be equal to 0. D has to be a perfect square basically. So from here I can say that my discriminant, it needs to be a perfect square. And when can it be a perfect square? Let us find out our d, which is b square minus 4ac. So from here we know that b square is 16 p square minus 4 a into c, where my a is this, my c is 5p. So from here what do we get? And when I equate my discriminant to be 0, because it is just touching the x-axis, d, when I equate this to 0, what do I get? I get p cancelled out from this equation, and I would be left with 16p into p minus 5. This is what I would be left with. That means now this value, for this to be 0, of course I can have p value to be equal to 0 or p value equal to 5. However, I have to say that it has to be a perfect square. Now, when can this entire value be a perfect square? Now, of course, p has to be somewhat value which is greater than 5. In the question, they've given us that p belongs from 0 to 10. Now, from 0 to 10, let me just put each and every integral value of p, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up till 10, and see for which value I would get this to be my perfect square. And that value of p would of course become my maximum value. So from here, what do we get? Let us hit and trial on this to make this a perfect square. P minus 5 is equal to, let us make this a perfect square. So first let us put the value of p to be 0, entire thing becomes 0, so it is not a perfect square. 0 is not considered to be a perfect square, of course. If I put p is equals to 1, this would become 16 minus, of course, I have to take my p which is greater than equal to 5, greater than 5. Because if I take any value which is less than 5, this entire term would become negative, and negative terms are never a perfect square. So I have to take p which is greater than 5. So what if I take my p to be 6? In the first case, I would have 16 into 6 into 1, not a perfect square. P is equals to 7. I would have 16 into 7 into 2, not a perfect square. Let's take p is equals to 8. I would have 16 into 8 into 3, again not a perfect square. If I take p is equals to 9, I would have 16 into 9 into 4. This seems to be a perfect square. You can see that 16 can be square rooted, 9 can be square rooted, 4 can also be square rooted. So p value has to be equals to 9. That means if p is 9, how can I transform this? This would become, if my p is 9, so this would become p minus 9 whole square is equals to 0. That means the maximum value of p for which the roots of this equation are rational is p is equals to 9. And what have they told us? That q is the maximum integral value of p. That means this is equal to q. Now what have they told us? So the first part of the question is done. I hope you must have understood here till here. Now they've told us in the second part we have to find out the area of region which is bounded by 0 to y to x minus q square. Now let us draw the diagram. Y less than equal to x minus q, which is 9 whole square, less than equal to 0. So our graph would be somewhat like this. sorry, this is touching the x-axis, and this point here is nothing but 9 comma 0, and we have to find out it from 0 to q. X is from 0 to q, that means from 0 to 9. This is the shaded portion that we have to find. This is 0 comma 0. So simply we can integrate from 0 to 9, and our equation inside would be x minus 9 whole square. This becomes dx. Now if I was to integrate this, I would get x minus 9 whole cube by 3, and this would become from 0 to 9. Let us insert the values here. We would get 9 minus 9, 0 for the first one, and we would have minus. This would become 9 cube by 3. So from here we would get 243. Now of course my answer is coming out to be negative. However, if I, let's say, change the limits from 0 to 9, this portion is coming out to be negative because so I'm sorry, this wouldn't be negative because I have minus 9 inside as well. This is minus 9. So once I minus comes out, this would become plus 243, and this becomes my answer. So this shaded area is 243 units. We can simply say the dimension to be units. Let me repeat the question, the solution of the question once again. They had given us a quadratic equation. They had given us an unknown variable in the quadratic equation, and they told us that that unknown variable is an integral value and it lies from 0 to 10. Now they told us what would be the maximum value of that unknown variable, which is p, for which our equation has rational roots. That means we must have real roots. Rational roots means real roots, and maximum value comes only when it is the just threshold portion. And when does our threshold portion come for real roots? When it touches the x-axis. Basically, if it is touching our x-axis, that means we would have real and equal roots. That means our discriminant would be 0 at that portion, and our discriminant would be a perfect square. So what we did was we equated our discriminant to be 0 for this equation. We found out our d, which was b square minus 4ac. From there we got an equation, and now this equation we had to make it into a perfect square so that we can get real and equal roots. Now to make it perfect square, what we did was we used hit and trial method from 0 to 10. Now in the equation you could see that we had p minus 5 also as one of the portion of that value. Now of course, if we have a value which is perfect square, it can never be negative. That means p has to be always greater than 5. If p is greater than 5, now we have to hit and trial only 3 or 4 chances, which is 6, 7, 8, 9 and 10. So we did hit and trial method, and we found out that with p is equals to 9, we are getting it to be a perfect square. So my maximum value of p would be equal to 9, for which my roots of this equation are rational. Now they've told us that q is the maximum integral value of q. That means my q is also 9. And now comes our area under the curve question. They've told us to find out the area of region, which is from 0 to x minus 9 whole square. X minus 9 whole square, we draw the diagram, we get our roots. We have to integrate it from 0 to 9 comma 0. They've given us the limits as well, which is from 0 to q. From there we integrate and we find out our answer to be 243. So this was how we solve question which is a mixed concept of quadratic equation, its graph and area under the curve. Let's look at one more question. The odd natural number a such that the region bounded by y is equals to 1, y is equals to 3, x equals to 0, and this is. So again, let us draw the diagram. Let us first draw our coordinate axis. This is our coordinate axis. Now they've told us the first line is y is equals to 1. So it is going to be this one. This is our 1 comma 0, let's say. What is our second line? Y is equals to 3. So this is my second line, 3 comma 0. They've told us another one is x equals to 0. That means my y axis. This line here is my x equals to 0. This is my y is equals to 3. Is equals to 1, and the other line is x is equals to y to the power a. If I convert this would become y is equals to x to the power 1 by a. If I put the value of x to be 0, y would also come out to be 0. That means this is one of the points that is included. And let's say if I put a value to be any natural number, let's say it is 1 by 2 for example, or let's say it is 1. So y is equals to x, it would come out to be a straight line. However, now when I transform into a curve, what would happen is it would basically become a curve which is above the x-axis. Y can never be negative here because a is an odd natural number, and any value whose power is less than 1, it can never come out to be negative. So from here I can say that my curve would somewhat be, let's say, like this. Again, I'm not assuming how my curve would be, I'm just letting it know that how my curve would be. So the area bounded by all these four things. So basically we're talking about this. Now either my answer could be a1, or I can also find out this area as well. This is also the same thing, which is bounded by x is equals to 0 and my curve. Now this entire a1 plus a2 is not my answer. My answer is basically, or my area is basically a1 or a2. From here you can see that it is of course a symmetrical graph, so my a1 would be equal to a2. Only difference is that my one of my areas would come out to be negative, another one would be positive. So basically the absolute values would be similar, so I can say that a1 modulus would be equal to a2 modulus. Now let us find out our answer. Basically what we can do is we can integrate the y function, this curve, in terms of y. So what is my x? X is y to the power a, and I can integrate this from 1, sorry, this is not 1 comma 0, this is 0 comma 1. Since it is in the y axis, so this becomes 0 comma 3. So from I can integrate this from 1 to 3, and here I would have y to the power a dy. Now let us solve this integration. What do we get? We are going to get, this would become y to the power a plus 1 upon a plus 1, and from 1 to 3. Let us take this to the next page. Here we would have 3 to the power a plus 1 upon a plus 1 minus, we would have 1 to the power a plus 1, so it would be 1 upon a plus 1. So here we have 3 to the power a plus 1 minus 1 upon a plus 1. Now what have they told us? That this value, this area value, this is equal to 364 by 3. This is equal to 364 by 3. Now of course this value can either come out to be positive or negative because it lies in both the axes. So let me take both the values. For whichever I would find out the value of a, that would become my answer, or if I can find out multiple values of a as well. So now let us try to solve this. First let's take the positive sign. From here what are we going to get? 3 to the power a plus 1 minus 1. This would be equal to 364 a plus 364, and here we would have, this would become minus 3, and this would become one more 3 multiplied, so this would become a plus 2. So from here what do we get? 3 to the power a plus 2 minus 364a, this value is equal to 367. Now how can I solve this? I basically have to use hit and trial method, of course. There is no other way of solving it, or I can use my logarithmic function to find this answer. So by just looking at this, I hope you all know what are the tables of 3. If I was to power continuously 3, what I would get? Let's say if I take a to be, or a value to be, let's say 4. So what would I get? This would become 3 to the power 6 minus 364 into 4. This is equal to 367. From here 3 to the power 6. What is my value of 3 to the power 6? 3 3s are 9, 9 3s are 27, 81, 243, and from there I would get 243 into 3. So from here basically I would get 243 into 3. However, again this value comes out to be more, so it would become negative, so it is not my answer. So this gets rejected. Now that means I have to choose value of a which is greater than 4. Now from this at least we've understood this thing that a has to be greater than 4. Now let's say if I take a is equals to 5. What if I take a is equals to 5? This would become 3 to the power 7 minus 364 into 5 is equals to 367. So from here my 3 to the power 7 would become 3 243 into 9 minus this would become 5 4s are 20, 5 6 are 30 plus 2 32, 5 3s are this would become 18, 367. And if I look at this carefully, this value would somehow be greater than 1820 and it would be close to 2430. So this can be my correct answer. So let me check it properly. 9 3s are, this gives me 27, sorry, 9 4s are 36, 36 plus 2 this gives me 38, 9 2s are 18, 18 plus this gives me 21. So if I try to solve this, what am I getting? 367 only. So this is my answer. So basically I've solved the first portion. So for a is equals to 5, I'm being able to satisfy my equation. Now what if, let's say I was to take the negative sign, 3 to the power a plus 2 minus 3, this is equal to 3, sorry, let us remove this directly, minus 364a, this is equals to minus 367. Now is there any value of, so what are the values of a for which 3 to the power something would be less than 364 into that value of a? Now since I'm taking it to be negative, a can always be positive. Now as I keep increasing the value of a, of course 3 to the power something is going to get increased, so this can never come out to be negative. For this to be negative, of course this value has to be less than this. However, as I keep increasing a, it is not going to come. That means no possible values of a are coming for this case. So thus my a is equals to 5, this becomes my answer. And what was they asking us? The odd natural number a. So basically this a is equals to 5, this is my answer. Again, a fairly easy question. The only thing is that you had to understand that the graph that was drawn is symmetrical, and since it is symmetrical, that means it can be, and they haven't told us anything about the positive or the negative side, so you have to consider both the areas. Once you consider both the areas, you get an equation. They have given us the value of area as well, and once you get the equation, now the difficult portion of the question actually starts, where you have to hit and trial and find out what would be the value of a. So what you do is you simply just assume a value of a, and a, let's say I chose 4, you could have chosen 6, or let's say 3. Based on that, based on the value that you would get from the first, you could have identified what would be the next value that you could have chosen for hit and trial. And let's say I got it in the second chance only, you could have gotten it in 3 or 4 chances. So again, it is not very difficult equation to solve. In maximum, I guess 4 chances you would have gotten the answer. And then we checked the entire question for negative sign as well. For it, no values of a was possible, so that is how we got our answer. So that was all for this chapter. Our integration portion is basically completed. Now we will be looking into another chapter, which is differential equation, which is basically a mixed concepts of differentiation as well as integration. So that was all for this chapter. Thank you.